So let's find out what we can do, what we can achieve with Swift OpenAPI Generator. If you had a chance to work with any external API, you probably had to read a documentation. The documentation which guides you how to use the API properly. OpenAPI is an industry standard to describe how API works. It can be easily read by the technical and non-technical people. The thing that OpenAPI is particularly known is the ability to create interactive documentation. But it also can do a lot of other stuff like code generation and much, much more. So let's inspect how the OpenAPI file looks. Hey, I'm Łukasz, and today we're going to talk about Swift OpenAPI Generator. Anyone here try to use it? What? Oh, like 10 people, okay. That's good. Maybe use OpenAPI contract? Yeah, a bit more. Okay, so let's go. It's my second time here in Turin at Swift Heroes. 2 years ago, I was here as an attendee, and this conference is kind of special for me, because this is when I started to wonder, maybe I can do it. Maybe I can stand here. Maybe I can talk to you. So when I got home after the conference, I started to gather ideas, prepare my proposals. I sent some submissions, and nothing. I received only rejections, but I think this is how it goes, right? Usually when I heard someone saying about their adventure as a speaker, they said, you need to try. Keep trying, keep trying, keep trying. So I did. Around a month ago, I was 400 kilometers from here. I was wrapping up my snowboarding season in Italian Alps when I received a very special email with my approval of my submission here. This is the day. I was very happy. This is one of the many beers I drank. Have you ever drunk the Jäger bomb? Yeah. See the Jäger inside? Yeah. Of course, rest of the beers I drank after I called it a day on a slope, because safety first, of course. So yeah, this is my debut. Thank you for being here. Thank you. It's a bit late. I think we are all tired. I still have some beers inside me after yesterday's aperitivo. Yeah, it's not the end of the talk, fortunately, but we're almost at the end of the conference. I don't know your plans for this evening, for the weekend, but I stay here for an entire weekend, and I love Italian food, like a lot. So probably I'm going to eat definitely much more than I should. And I think you will follow. But bear with me, last session of this amazing conference. Let's do it. For the almost 2 years, I work at Hitch as a senior iOS engineer. What's Hitch? In the simplest words, we are the French Uber. The company was founded in 2013 by two amazing people who were trying to help young Parisians to move around the Paris during the nights, after the parties, during the weekends, for an affordable price. So yeah, we still provide the ride-hailing service in a couple of markets in Europe and Africa. And we still follow the same mindset to make mobility accessible for everyone. Yeah, as I told, 7 markets, mostly French speaking, because this is the easiest as a French company. But we are much smaller than our competitors. We raised a lot of less money than they did. Our engineering team is just a fraction of our competitors like Uber and Bolt. But this doesn't prevent us from making bold decisions like we did last year. So company decided that we need to change something. We need to make a pivot, and we're going to rewrite entire platform. I mean, the apps, the servers, everything. So what does it mean from the iOS perspective? We started last year with tools implementation in a version 3. It was kind of a big task because it was 10 years old project with a lot of weird code. And like 2 or 3 weeks ago, I finally migrated the tools to the version 4. So we are like, right now we are up to date. For the whole time, we had a single app for passengers and our drivers. And so the app still is, but it was very big. So we decided we need to split it if you want to progress, if you want to deliver really good apps. Recently, we created our new design system called Flamingo, because we are pink. That's why Flamingo. Flamingo in version 4, which is completely written in Swift UI. I removed the Cocoa pods. I migrate the Cocoa pods to SPM with Twist support to be able to take advantage of Twist cache and Twist testing features. And during this talk, we're going to, I'll show you how we can use available tools that can help us focus on the things that really matter, except writing boilerplate code. And we won't use AI tools. We won't use ChatGPT. We won't use GitHub Copilot. So let's start with defining the problem we are trying to solve. So we had an app which needs to display some dynamic content provided by the server. So pretty much every app. In order to do that, we need to make an API call to our server. But to do it, we need to know several things, like what's the URL of the server, what HTTP method we need to use, what's the URL path. Maybe this request needs any parameters, and what we will receive as a response. Or maybe we will receive an error. What does this error mean? And if you are able to construct the URL, if we are able to call the server, we probably want to have some kind of abstraction over all the endpoints we are declaring in our code. But do we really like to write code like this, the code which is repetitive and error-prone? I don't, and I'm pretty sure that Krzysztof Zabłocki doesn't like it either, because he wrote entire sorcery not to do it. So I think that's true. So let's find out what we can do, what we can achieve with Swift OpenAPI Generator. And remember, after that. So if you had a chance to work with any external API, you probably had to read a documentation. The documentation which guides you how to use the API properly. OpenAPI is an industry standard to describe how API works. It can be easily read by the technical and non-technical people. The thing that OpenAPI is particularly known is the ability to create interactive documentation. But it also can do a lot of other stuff like code generation and much more. So let's inspect how the OpenAPI file looks. This is our app, the Hitch app, and the OpenAPI file that we're going to explore is about the products, which are the types of the ride that we can offer in this location. So every OpenAPI document needs to be declared with the version of the OpenAPI specification that it uses. Then we are providing the metadata about the API, like the name, the version, description, and who to contact to blame why something is wrong. Then we can define, or we should define, the list of our servers. Typically, we will define different URLs for different environments, and the other data that might be useful for the API users. Then we need to define the list of paths and HTTP methods that make up the entire API. Our API uses two operations under the product paths. The one with the get method is used for retrieving the list of the products, and the other one, post method, we will use it to create a new product. And again, some metadata to provide. They are optional, but we can benefit after the code generation. We will see that. And both our methods uses some kind of objects for the response or the request. And we should describe these models in the document. The first one, the get method defines only one response. So the server will always respond with 200, or this is what our backend engineers are saying. The 200 is the HTTP status for OK, so the successful operation. We see that this response will return some kind of JSON model defined with a JSON schema. And this declaration is a bit below. So as you can see, we will return some kind of object, which is the array of products. But for the models which are commonly used, we don't want to duplicate them. We can define like the reference for the entire model, which will live a bit lower into the entire schema. So this is the component section. We see our product defined. At first, we can define what's the required properties that this product use, and then we list all other properties that are making the entire object. We have two properties, which are the string types. We can define that are only the strings, but we can also be more specific and define the text format that the user should apply. We can also define the length of the text we need to provide. For the properties, the numeric properties, we can define if it's the number, the floating point number, or if it's the integer. And in the schemas, we can also nest other objects. So like with the city, is the entire declaration, but it's also the property of the product. And quickly, let's review our second method, our second operation, which is responsible for creating the product. It uses the same path, products, but it's defined for the other HTTP method, for the post. And this one accepts the JSON object as a, in the request. And what we are doing here, we are defining the same some schema declaration which live outside our document, because we can do that. Mostly, if the API is big, it's a good practice, I think, to split the entire document into separate files, but anyway, we can reference to the other file. For this operation, we have two different response defined. The first one is 201, which is the HTTP code for created. And the other one is a 409 error, which is HTTP error for conflict. OpenAPI declaration can be written in either YARN or JSON, but to be honest, I've never seen the JSON declaration. Maybe that's why. In my opinion, it looks kind of weird with all of the curly braces. I don't like the YAML either, because I always mess up the indentation, but looks much cleaner. And I told you that OpenAPI is known for generating the interactive documentation, and that's it. I guess most of you seen it. Okay, so time for some Swift code. The entire story with Swift OpenAPI Generator begins during the last WWDC. But thanks to the Apple Vision Pro, the WWDC sessions were full of sessions about the spatial computing, the immersive apps, but also the Swift data, the macros. But there was this one, not most popular, but brought my attention, made Swift OpenAPI Generator. So what exactly is Swift OpenAPI Generator? This is the Swift package plugin which takes the OpenAPI document as an input and generates some Swift code for us. This generation happens at build time, so we are sure that generated code is always up to date, and we don't need to commit it to our source code. Adopting the plugin is pretty easy. It requires 4 quick steps. Let's see what are those steps. First of all, as always, we need to define some dependencies. Then we need to enable package plugin and set up it to run on every build. Then we need to add to our sources the OpenAPI document we just reviewed. And we need to add some kind of configuration, and this one we will see in a second. This is something you probably know. We have the package Swift file. We are defining the dependencies we are going to use, and our product dependency is the Swift OpenAPI runtime, and the plugin is Swift OpenAPI Generator. If we want to set up the whole thing in an Xcode project, not in a SPM package, we need to go through Xcode options to fetch those dependencies and set up the dependency and plugin in the build settings. This is the entire YAML file that we're going to use. And this is the configuration where we need to define what we expect from the Swift OpenAPI Generator. We expect types. So let's build the project and see what happens. As I said, this is my first public speech, so I didn't want to mess with demo gods. It's super late, so I have the safe option with code snippets. The most important thing that comes after the generation is the API protocol, which contains all the operations from our document. We're going to need this protocol to create some kind of API client, or if you want to test, create a test mock. All our servers we defined in the document are now ready to use foundation URL objects. And all our operations are listed in an enum, and they are named by the operation ID we used in our declaration, And this is where I told you that it can be beneficial. It's optional, but it can be beneficial after the generation. And this is why, because we have the exact name of the operation, and we also have inline documentation from the summary and description. Each operation has dedicated input and output types, which closely match the YAML definition namespace. So we are going through operation ID. Then we have our output object. Then we go by status code and the response body. Then we have JSON payload, and finally our products. And if you can see on the left side, this is pretty much what we defined in YAML declaration. Output enum covers all possible responses. So we have the created one, 201, conflict response for 409, and there's also the one named undocumented for all other status codes that were not defined in the document, but it still can happen. And last but not least, we have our components transformed into Swift structures. So, is there something more we can achieve with Swift OpenAPI Generator? Of course. We can extend our configuration file and try to generate some kind of client. Again, we need to define some dependencies and build a project. And as a result, we have this client, URL session client, which use some server from our server list, and transport, which is highly configurable, so we can use the URL session instance you always use. And 2 lines at the bottom, you can see how quickly you can ask the API for the data. And the get product, so our response is the enum, so we can switch over all possible responses. But here I just wanted to ask for the products. We're almost there, but not yet. Swift OpenAPI Generator can also generate server stubs for Vapor projects. But before I'll show you how to do it, and if it's really possible, let me quickly introduce you to Swift Vapor. So at the end of the 2015, Apple announced open sourcing the Swift language and made it available to run on Linux. Not far from, not a bit later, Tanner Nielsen and Logan Wright created the first version of Swift Vapor, which is the web framework for creating the web applications, APIs, and server applications in Swift. Vapor is made up from several components. One of them is Fluent. This is our ORM, which handles the communication with database. Fluent has many database drivers available, so if you like SQLite or MySQL or any other, you can use it. Other component is Leaf, which is a templating engine for creating dynamic HTML pages, so we can create the website with a Swift. But why would we use Swift as a server-side technology, since there's plenty of major languages and frameworks which can do it probably better? Of course, because it's Swift. We are at the Swift conference. I think most of you at least likes writing in Swift. So for us, iOS developers, it may be very handy to not need to learn another language just to create a simple backend application. Besides that, Vapor is really lightweight and highly performant in terms of how it works, and in comparison to, for example, Node.js or PHP applications, which are considered as the really good in a backend. So how to use the Swift Vapor? Let's try to replicate the YAML document we saw without generating, just write it manually. So we can define the product model, and it indeed needs the model protocol, because this allows Fluent, which is our ORM, to handle the database connection, so we can save this product into a database and retrieve from the database. Schema is the name of the table to store the objects. It's required by the model protocol. And then we have the list of properties with property wrappers, which annotates the name of the fields in a database. And thanks to the fact that Vapor is heavily relies on Codable, we can store the entire city object without defining it as another model, I mean the database model, but it can be stored as a JSON in a database. Probably it's not the best idea, but just for being simple. And the last one, content inheritance, for us to be able to send this object as a JSON response or accept this model as a JSON request object. And then when we have our model, we need to define controller, which will control the routing of all HTTP requests. So here we are going to handle all requests that are going under the product's URL, under the product's path, and we're going to send the get methods to the list model, to the list method, and the post to the create. So fetching all the objects from the database is as easy as you can see. What's important here? Make sure to notice this request parameter which goes inside this method. And again, to create one, we are decoding the incoming request into a product object, and we are trying to save it in our database. Those ones are crucial in Vapor, because whenever we need to handle any request and we want to make another asynchronous operation like querying a database or saving to the database, we need to do it in some kind of loop. Keep it in mind. Whoop. So Swift OpenAPI Generator can create the server stubs. So in order to do that, we need to add Vapor dependency. And if we build the project, we won't see that. We only had the API protocol, which is defined by the types, not by the server declaration in our schema. But if we create our controller, which inherits from the API protocol, we have these empty methods to declare and to implement. But as you can see, there is no request. And this is a big issue. And first time I tried to use it, I didn't notice that there's something missing. When I realize it, I go through the Swift OpenAPI Generator for Vapor repo. I try to find the issue. Maybe someone had the similar issue as me. And indeed, there was a discussion how to use it properly. And the response from the creator of this or maintainer of this package, and this is right now the official way to how to handle it, was to fetch Swift dependencies from point 3 to create the middleware which will take the response and inject to every controller, every request we need to handle. Yeah, it works, but I think it's kind of far from like ready-to-use, out-of-the-box solution. Which brings us to the last very quick session of this talk, which is the issues with Swift OpenAPI Generator. If you remember, I showed you this reference to another file, which is completely fine with OpenAPI, but it's not with Swift OpenAPI Generator. There is a big discussion on GitHub with feature requests for this one, and I agree with the Fabin user that without it, the tool is extremely limited because we can't use it in Hitch right now, but whenever this one will be implemented, I think it can be very, very useful. We're close. What? I spoiled the final. Yeah, this is really close. That's really the end of my talk. Thank you very much.
Does it work? No way this was your first talk.
It was.
You really rocked. Thank you so much.
Thank you.
And moving back for a second on your first part of your presentation, I mean, I feel a little bad to be, involved into the rejection for the first year. Now, for what it's worth, last year I've applied to another conference to give a talk, and I was rejected myself. So I know the pain.
Yeah, but as you said, I think every conference receives like hundreds, at least hundreds of submissions, and the available spots are really limited.
But I'm glad we were able to make it up this year. So
fortunately, thank you for that.
Okay, that being said, lots of questions here.